Welcome to this video. Here I am going to discuss about position fixing. Well, the celestial body is a sun. So in your syllabus we are using only sun as a celestial body. So there are various methods and your syllabus contains latitude by meridian altitude, intercept, long by Chron and Polaris. However, we are going to discuss intercept and long by chronometer in this video. So let's start. So before I start with intercept method, let me explain about position line. Well, suppose this is a lighthouse and lighthouse is a fixed object. So we can fix the position by taking the bearing, or we can also fix the position by taking the distance of the fixed object. That is how we can do. We know it very well that the earth and the celestial sphere both are concentric. It simply means that the center of the earth and the center of celestial sphere is same. So as per the geometry, the position of the celestial body on the celestial sphere can be transferred on the surface of earth, and that is called GP, geographical position. So here in this system, what we do, instead of this fixed object on the land, this is the lighthouse, we replace with the celestial body, we replace the geographical position of the celestial body, and we are able to fix the position. So that is a very general explanation of position fixing. Now the size of the arc will be very large because the distances measured are pretty large. So it may not be practical to draw such a huge circle with such a large distance. So what we do, instead of arc, let me just underline, instead of arc, a tangent is drawn on the arc, right? You can see here, this is the tangent which has been drawn, and this tangent is called LOP, line of position. Sometimes it is called position line, PLOP, and well, the correct name can be CLOP, that is celestial line of position. Actually, these are the celestial line of position, and if we see carefully, these lines are perpendicular to azimuth or bearing. So this is the radius, by the way, and this is tangent. And we know it very well that the tangent is always perpendicular to radius, and that's why the PL is always perpendicular to azimuth or bearing. Now let's talk about intercept method. It is also called as Mark-St. Hilaire method. So what we do in this method is we need to find the angular distance of a celestial body from a DR position. DR position is the dead reckoning position, which is not a accurate position, but it is used to find the correct position. So we need to find the angular distance, and that angular distance is nothing but zenith distance. And since we are computing this, we can call it as calculated zenith distance. Now we can obtain true zenith distance from the true altitude by observing sun. So once we obtain the sextant altitude, then we can easily work out that true zenith distance is 90 degrees minus true altitude. So a true zenith distance is obtained. Well, the difference of calculated zenith distance and true zenith distance is called intercept, and it is expressed in minutes of arc or nautical miles. So we can say 1 minute of arc is 1 nautical mile. So let's talk about the steps which involve the calculation, and the first step is to obtain calculated zenith distance from a DR position. So we have this rational horizon diagram where this is east, west, north and south. Well, the observer is at Z, is at the center. So WQE, that WQE is equinoctial, and suppose this is the declination. So this is declination circle, the dotted line, and the celestial body is going to move along this declination circle in 24 hours. So it is rising like this here, and there is a meridian passage, that is the noon time, and the body is going to set like this. That is how the sun is going to move, or in fact any other celestial body. So suppose the celestial body is here at X, so we are having PZX, this triangle. Let me just underline this. This is the triangle PZX. So basically we are talking about the solution of a PZX triangle by using cosine formula, and this is the formula which says cos of calculated zenith distance is equal to cos P cos L cos D plus minus sin L sin D. Simple and straightforward formula. So here L is the latitude and D is declination. Well, we take positive sign when both are of the same name, and we take negative when they are of opposite name. Of course, this P we need to be careful, and if the LHA is more than 180 degree, then we take P is equal to 360 degree minus LHA, and if LHA is less than 180 degree, then we take P is equal to LHA. Let me just explain this further, how this P has been arrived. So here in this diagram, if you see that this side is east and this is west, this is at the center. So suppose, so this is 0 degree, by the way, this is 180 degree. So suppose you are having the celestial body here, so this arc is nothing but LHA, and this is also angle P. Well, this is pole, so P is equal to LHA when LHA is less than 180 degree. Now look at this diagram. Here suppose, okay, well, this is east and this is west. Suppose body is in the easterly direction. Well, this is going to be LHA. So obviously this angle is P, and we can see easily the P is going to be nothing but 360 degree minus LHA, and here the LHA is greater than 180 degree because this is 180 degree. Well, this is the way we need to figure it out, and we need to remember this P. Now coming back to the derivation, we will use the cosine formula for derivation, and cosine formula says cos of Zx, that means cos of this side, is equal to cos of adjacent, that is Pz and Px, plus we have sin Pz, sin of Pz and sin of Px, and the angle P. That is the cosine formula which we have written here. But we know it very well, this Pz, P to Z is nothing but 90 degree minus latitude, because this fellow is latitude, so this is going to be 90 degree minus latitude. This is 90 degree minus latitude. Similarly, this fellow is 90 degree and this is nothing but declination, so Px is going to be 90 degree minus declination, and this holds good that both are of the same name. And here you can see this is your equinoctial, this is north pole, so the latitude is also north and your declination is also north. So what we'll do, this Zx is zenith distance and we can write as calculated zenith distance. Then this Pz, cos of Pz, it will become sine latitude, because cos Pz will be cos 90 degree minus latitude, cos 90 degree minus latitude is sine latitude. Similarly, the Px will, cos Px will be sine declination. Well, likewise, this sin Pz becomes cos L, and this sin Px becomes cos T, and cos P remains same. So, let's rearrange this, and this term let's write initially. So, we write cos P, cos L, cos D plus sin L, sin D. So, this is the intercept formula. Well, we computed this formula considering latitude and declination as a same name. Suppose they are opposite name. That means Px will be 90 degree plus declination, and here we can say that declination is south, we have assumed, and latitude is north. So nothing will happen to the latitude, but for declination is south, so Px is 90 degree plus declination. So cos Px will be cos 90 plus declination or minus sine declination. So this sine declination become minus sine. So here we have this formula. Cos calculated zenith distance will be cos P, cos L, cos D minus sin L, sin D, when both are, that is latitude and declination, are of opposite name. That is opposite name. So we arrive to this formula that cos of calculated zenith distance is cos P, cos L, cos D plus minus sin L, sin D. The plus means latitude and declination are of the same name, and minus we take when both are opposite. So now let's move to the step 2, and step 2 is we got to obtain true zenith distance from true altitude of the celestial body observed. So we have sextant altitude, then we apply index error on the arc, off the arc. If it is on the arc, we subtract. If it is off the arc, we add. Then we obtain observed altitude. Then we apply dip, that is height of eye. Alright, and this is always negative. Well, you can have a look here at this picture, and here if you see, this is dip, and say suppose this is 4 meter, 3.8 to 4 meter height of eye, the dip correction is minus 3.5 and so on. Then we have apparent altitude. Then we need to apply total correction. Here you got to be careful. There are two tables. One is October to March, another one is April to September. So you need to see which date you are observing. Accordingly, choose the column, and then you look up for the lower limb or upper limb. If this is lower limb, you got to add plus, and if it is upper limb, then you got to subtract. Then you obtain true altitude, and the difference subtracting the true altitude from 90 degree, you get true zenith distance. Now what we have to do, we need to compare calculated zenith distance and true zenith distance. The difference between the two expressed in minutes of arc or nautical mile is called intercept. So let's talk about case 1. Here what is happening? Well, this is your dr latitude and this is your dr longitude. And imagine that this is the dotted line and this is the dr position. So we computed the distance of celestial body, and that is calculated zenith distance, that is from dr position to celestial body. That is the calculated zenith distance, the zenith distance which is calculated using dr position. Now imagine if the true zenith distance is less than the calculated zenith distance. So this is the true zenith distance and this is less than the calculated zenith distance. That means you are towards the celestial body. So the perpendicular distance to the zenith distance is going to be PL, and which is shown with this green color. So the difference between this green line and this yellow dotted line is nothing but intercept. Well, we can remember that true zenith distance is less than calculated zenith distance. In that case, the intercept is towards, and it simply means the intercept is towards the celestial body. You can have a memory aid which says Tom like Tim. That means true, less, towards. Well, this is Tom like Tim. So true, less, towards. So if the true zenith distance is less, the intercept is towards. Now let's have another case, and here is as simple as that. Well, this is your dr position, dr latitude and dr longitude. So in this dr position, this is the dotted line, and we are having the calculated zenith distance. But in this case, the true zenith distance is more than calculated zenith distance. So you can say the true zenith distance, this TZD, is more. So it has to be more than only in this case only when it is away. Well, the difference between this dotted line and this green line, that is the PL, this is called intercept. So let's have this memory aid. The true zenith distance is more than calculated zenith distance. The intercept is termed as away. So intercept is away from a celestial body. As a memory aid, we can have this Tom got away. That means true, greater, away. That means true zenith distance is greater. That time the intercept is away. So let's have these examples which will give you a better idea. Suppose azimuth is 060 degree true. Then you got to find the position line. Well, let's have this diagram, and here this is north, this is north, this is south, this is east, and this is west. So we talk about azimuth as 060, that means this is the azimuth. Suppose this is sun. So 90 degree to azimuth is going to be the position line. So how to obtain? Suppose this is 060, you add 90, that is 150, then you add 180, it is 330. So the position line is 150 degree to 330 degree. Well, this side is 150 and this side is 330. That is how we write position line. So now let's move to the example 2, and here suppose given calculated zenith distance is 60 degree 10 minute, true zenith distance is 60 degree 15 minute, azimuth is 050 degree, we need to calculate intercept and position line. So calculated zenith distance is 60 degree 10 minute, true zenith distance is 60 degree 15 minute. So we realize that true zenith distance is more. So we have the formula Tom got away. So true is greater than intercept is away. So 5 minutes away. Well, we can easily obtain position line. So it is 50 degree plus 90, we get 140, then plus 180, it is 320. So we take these values 140 to 320. Now coming back to the diagram, this is away. So that means this is a celestial body, this is calculated zenith distance which is taken from dr position, and away, that means true zenith distance is more. So we have this position line. Well, the difference between the two is intercept, which is away. Now let's reinforce this another example which says calculated zenith distance is 60 degree 10 minute, true zenith distance is 60 degree 5 minute, azimuth is 2 to 5. Again we need to calculate intercept and position line. So calculated zenith distance is 60 degree 10 minute, true zenith distance is 60 degree 5 minute. So true zenith distance is less. So Tom like Tim. Well, true. So zenith distance is less, intercept is towards. So intercept is 5 minutes towards. Now the position line 2 to 5, you got to add 90 degree, it becomes 315. Then again you add 180 degree, it is 495. Well, we have the measurement only up to 0 to 360 degrees, so we need to subtract 360 degree, so we get 135. So basically we have the position line as 135 degree to 315 degree. Now this is your dr latitude, this is your dr longitude, and from here this dotted line we have done the calculated zenith distance. Suppose this is the celestial body. Now the intercept is towards the celestial body, so true zenith distance is less. So this is your PL, 90 degree to that, and that is how it can be expressed. The position line is 315 and 135. Let's move to the another example. Here the calculated zenith distance was 70 degree 10 minutes. True zenith distance is 70 degree 6 minutes. The difference of the two is 4 minutes, and it is towards because the true zenith distance is less. Azimuth is 200 degree true, so position line will be 110 to 290 degree true. And this is the diagram. And here you can see that this is the true zenith distance and this is calculated zenith distance. Well, we can see clearly the true zenith distance is less than the calculated zenith distance. The calculated zenith distance is taken from dr latitude and dr longitude. Alright, true zenith distance, here there will be PL and it will be towards the celestial body. Well, the celestial body is here and the PL is towards the celestial body. Now let's talk about next step, that is step 4. We need to obtain azimuth and position line. Well, it's pretty simple. A is equal to 10 latitude upon 10 P, and here it is named opposite to latitude except our angle is between 90 and 270 degree. Similarly, we need to find B, which is 10D upon sin P, and this is named as declination. Now if A and B are of the same name, then you got to add and retain the name. If they are of opposite name, then you got to subtract and retain the greater name. Now we got to obtain true 10 azimuth, which is 1 upon C cos latitude. So we get the azimuth. And this azimuth naming is going to be pretty simple. If this azimuth, whatever you get in 2 degrees, it is going to be north or south depending upon the name of C, and east or west depending on the LHA, or the body is rising if it is rising, or if it is setting, or this is AM time or this is PM time. We will be having different clue. So let's talk about this example, which will give you some idea like how these problems are solved. So we talk about 22nd September 2008. The time is this is PM time, and the DR position is given 48 degree 20 minute. Longitude is 085 degree 40 minute. GPS time is given, which is 10 hour 09 minute 38 second. Well, usually the GPS is a 0 to 24 hours format, but imagine that it is a 0 to 12 hours format. It can be a 0 to 12 hours format, but usually it is 0 to 24 hours format. So we are having the GMT time. Well, the GPS is trying to show the GMT time. So we are having this GMT time, which is 10 hours 09 minute 38 second, or it can be 22:09:38. So let's assume that there could be ambiguity. This 10 hour could be AM or it could be PM. Well, this is the GMT time. In the question it is mentioned as PM, but this PM is the local time. So what we do, we apply longitude in time, and longitude in time is 085 degree 40 minute east. So we divide this by 15, we convert into hours, minute and second. So we have 5 over 42 minute and 40 second, 5 over 42 minute and 40 second. We know it very well that longitude east, GMT least. So GMT least, that means LMT is more. So we are having the LMT, and what we do, we got to add. So once we add 38 and 40, we get 18 minute plus 1 minute extra, which we carry here, 9 plus 1, 10, and that 42. Then this is 52, and so on. All right. And then 10 plus 5, 15. Similarly, we are having 03, 52 and 18. Let's not work out about date. First of all, let's focus on time. If you see, this is 03 local time and this is 15 local time. Then obviously the question says the PM, that means this is the correct one and this is wrong. So let's ignore this part. Let's ignore this part. Ignore this part. All right. So we are having the local time as 15, 52, 18, and now let's put the date here, which is 22, because that is the date given in the question, and let's work back the date. Now we arrive at the GMT date. So let's write the GMT time, and the GMT time here is 22, 10, 09, 38, and let's write the month. Well, this month you can write initially also, September, or you can write at the end, depend whatever format you prefer. Then what we do, we need to focus on GHA. GHA, we need to look at the almanac, 22nd day, 10 hour, that is 331, 51.4. And then we look at the increment, which is 09 minute 38 second. Similarly, we look for the declination 0 degree 05.6, and we examine that the declination is decreasing. So we take the value of D, that is 1. So we have the value of declination as 0 degree 5.4 minute north, and the GHA 334 degree 15.9 minute. Well, the technique of finding GHA and declination through almanac has already been discussed. So I am assuming that you guys are familiar with that. So what we'll do now, we need to apply longitude east. Well, longitude east given in the question is 085 degree 40 minutes. So here the longitude east is 085 degree 40 minutes. So we have GHA, longitude east, GHA least. So LHA is going to be more. Then that means you got to add. So after adding, we get 419 degree 55.9 minutes. Well, this is more than 360 degrees, so we need to subtract. So we have 059 degree 55.9 minutes. And now we know this LHA is less than 180 degrees, so P is equal to LHA. So we have obtained the value of P. Now the latitude 48 degree 20 minute, this has already been, this is the DR latitude. So with these information, declination, latitude and P, we need to compute the calculated zenith distance. So we have this formula, cos of calculated zenith distance is equal to cos P, cos L, cos D plus minus sin L and sin D. We use plus sign when latitude and declination are of the same name. So here declination is 0 degree 5.4 minute north and latitude is 48 degree 20 minute north. So both are of the same name. So we got to use the plus sign. We have the value of P, we have the value of L, that is latitude, and we have the value of declination, that is D. After applying everything here, what we get calculated zenith distance is 70.4726, or we do the round off, we get the calculated zenith distance is 70 degree 28.3. Well, this is pretty important, and now we got to use with the help we got to compute the true zenith distance. So to find true zenith distance, we apply sextant altitude 20 degree 4.9, then we have index error minus 2.2, that is given in the question. We get observed altitude, then we apply dip, which is for 25 meter, and we need to subtract dip. Dip is always subtracted, which is minus 8.8 the value. So we get apparent altitude as 19 degree 53.9. Then what we do, we need to apply correction, and the correction we take it for upper limb, and we got to be careful with the column. So we have this value 0 degree 18.4. So we have true altitude 19 degree 35.5. We subtract this from 90 degree, and we get true zenith distance is 70 degree 24.5. So this was the calculated zenith distance, 70 degree 28.3, and then we have true zenith distance, which is 70 degree 24.5. So we see the true zenith distance is less, that is Tom like Tim, that is 2 hours. So the intercept is difference of the two, which is 3.8 minute 2 hours. Now we need to find the position line, and for that we need to work with ABC table. And if you see here, A is equal to 10 latitude upon 10 P. The value we can write in 3 digit. This is 0.651, and it is south because the latitude is north. So A is named opposite to latitude, that is south, except our angle is between 90 and 270. Now the value of B, it is 10 declination upon sine P, which we get 1.8 into 10 raised to the power minus 3, and same name as declination. Well, 10 raised to the power minus 3, we can write 0.0018. This 0.0018 we can write 0.002. So this is so we have the C, this is south, this is north. So C is, we need to subtract 0.649, and the south is the value of south is more. Then we get to find tan azimuth. Tan azimuth is equal to 1 upon C cos latitude. So azimuth is 66.66 or 66.7 degree. This is the value we have. Well, if this is 66.67 degree, then what we have to do, we can write like this. This is north, this is south, this is east, and this is west. This is 66.7. Well, this is azimuth. This portion is south because this value of C is south. Then it is going to be west. Why west? Because of the value of LHA. LHA, if you see here, LHA is 059 degree 55.9. So here the LHA is less than 180 degrees, so P is equal to LHA. And if the LHA is less than 180 degree, the body is going to be in the westerly direction. So here what we write west. So the value is southwest, so we have this southwest thing. This is the azimuth. So sun is going to be somewhere here. If that is the case, we need to find position line. Position line is 246.7. Well, this we need to add 180 degree. 180 plus 66.7, this is 246.7. That is what we obtained. And then we got to add 90, which is 336.7, then plus 180, which is 516.7. So we need to subtract 360 degree. We get 156.7. So we have obtained the position line, 156.7 degree to 336.7 degree. This is the position line, and this is the intercept. which is 3.8 minutes towards. So let's talk about longitude by chronometer or long by Chron, and in this method we are going to obtain longitude by chronometer. So again we are having this PZX triangle, and this PZX is a spherical triangle, and we know this cosine formula which is used for intercept, which says cos of calculated zenith distance is cos P, cos L, cos D plus minus sin L and sin D. We use plus sign when L and D, that is latitude and declination, are of the same name, and we use minus sign when they are of opposite name. So what we have to do, we need to just rearrange this formula, and this cos P, cos L, cos D, it remain in the side, and this fellow we try to bring in this opposite side. So this become cos calculated zenith distance. Now this plus become minus, and minus become plus, sin N and sin D. Well, this side we divide this cos L by cos L and cos D. So here we get cos P, and here we get this formula cos of calculated zenith distance minus plus sin L sin D upon cos L cos D. Well, it is not a calculated zenith distance, actually it is true zenith distance. So we know it very well. This calculated or true zenith distance is going to be 90 degree minus true altitude. So the cos becomes sin true altitude. It is just to make sure that all the values are written in a on the top, everything is sin. So cos P is equal to sin true altitude minus plus sin L sin D upon cos L cos D, and that becomes long by Chron formula. And here you got to be careful. First it is minus, then it is plus. So minus means when L and D are same name, and the plus means when L and D are of opposite name. That you got to be careful, because now it is opposite to what we are having with intercept. So this example will give you pretty good idea how a question by long by Chron has to be solved. Suppose the date is 4th May and the DR position is DR latitude 40 degree 30 minute north, longitude is 160 degree 30 minute east. So we observed the sun at local time, which is 0930. So we are having local mean time as 0930. Second is 0. Well, we are using 2-digit format DD, HH, MM and SS. LIT is 160 degree 30 minute east. So we convert into time by dividing 15. So we get 10:42:00. So longitude east, GMT least, LMT more. So we got to subtract. When we subtract, this is 09, this is 10, the date is changed. From 04 it becomes 03. So that is the GMT date and the month is May. Now what we do, we look at the almanac. First of all, we need to find GHA for 3 day and 22 hour, which is 150 degree 48.1 minute. The method to find GHA from almanac has already been discussed. Increment 48 minute 0 second, you got to look at the increment table, then you find this is 12 degree. Similarly, we talk about declination, which is 15 degree 59.4, the value of D is 0.7. So it is increasing, so we use plus sign 0.6, we get the declination 16 degree. Now the value of latitude is given in the question 40 degree 30 minutes, so we write the value of latitude here. So what we have to do, we need to find angle P. Cos P is equal to sin true altitude plus minus sin latitude and sin declination, cos L cos D. So here L and D same name, use minus sign. That's what I just discussed. So what we have to do, we need to find true altitude. For true altitude, let's talk about this. Sextant altitude is given 49 degree 41 minute. Index error is given, which is on the arc, so we got to subtract. So we get observed altitude, then we apply dip correction, which is minus 9.6, so we get apparent altitude. Now with lower limb we got to add correction and we need to see the required table, so we find true altitude as 49 degree 54.5. It is just a matter of practice. You need to practice, and so that you are able to find the value. Now what do? We apply everything and we obtain value of P, which is 36 degree 42.4 minute. So the body is in the east because in the question it is given the local time is 0930. Local time is the morning time, is AM time. So body is in the easterly direction. So we obtain angle P. So if this is angle P, the LHA is going to be 360 degree minus LHA. So the value of LHA is 323 degree 17.6 minute. Now the value of GHA we have already obtained, which is 162 degree 48.1. So the difference, GHA least, longitude east. So we need to subtract, and then what do? We find this longitude and we call it observed longitude, and this is 160 degree 29.5 minute. Now our target is to find ABC. So A is equal to 10 latitude upon 10 P, which is 1.146 south. B is equal to 10 D upon sin P, which is 0.80 north. The B is named as declination, so declination is north. A is named opposite to latitude, latitude is north, so this is south. Well, we can write these three values so that it's much easier to put the values and find the value. So here the C is 0.66. So 10 azimuth is 63.1, and then now naming the first part is south because the C is south, and the second part, that is east. Why? Because the body is in the easterly direction. So we have this 116.9 degree, that is the azimuth. Then position line is going to be 26.9 degree to 206.9 degree. I have already discussed how to obtain position line from azimuth, which is nothing but a perpendicular direction. So we are having this dr latitude and dr longitude, which is 160 degree 30 minute east. But we obtain observed longitude here, which is 160 degree 29.5. And if we know it carefully, this direction is east, this is west, and longitude is increasing. Alright, so observed longitude has to be on the left side of the dr longitude. So this is your observed longitude, which is 160 degree 29.5. Now we need to apply azimuth, which is 116.9 degree in this direction. So 90 degree to azimuth, we write this position line. That is how we can express. Well, the same question, if we obtain calculated zenith distance and use the value of P, you will be able to find calculated zenith distance, and then you can compare with the true zenith distance, which is obtained from true altitude. You will be able to find intercept. So method of working with the intercept and long by Chron, it is just simply the matter of using the formula. If you are working with long by Chron, you got to find angle P, and if you are working with the intercept method, you have to obtain calculated zenith distance.